Today on the show, time flies, but can AI slow down the illusion? Daniel and I ponder the warp speed passage of time and whether artificial intelligence can lend a hand in dialing it back, maybe just a smidge. And Cline, our favorite AI co-pilot, well, it gets experimental as Daniel shares a wild tale of his code editor venturing into podcast subscriptions, showcasing the quirky agentic side of AI. And speaking of agentic, is it agentic AI or just really smart tools? Well, we dive into what sets a truly agentic AI apart, sparking questions about independence, external tools, and a pinch of silicon-based self-awareness. Speaking of self-awareness, quantum computing meets the multiverse. Or does it? Google's Willow chip has sparked a debate between us on quantum breakthroughs, encryption fears, and how AI stands to evolve when our ones and zeros enter infinite dimensions. With multiverse musings, agentic ambitions, and the thrilling race to quantum supremacy, this episode will bend time and space as Daniel and I navigate the road to our AI-powered future here on...
They might be self-aware.
Hello, Hunter. How you doing?
The years? Where? I don't know where the year has gone exactly. It's time is moving too fast, I think.
Time is an illusion, but the illusion is moving too fast.
The illusion is way too fast.
It is.
I need a slower illusion, please. Can AI help there?
No, but interesting you ask where AI can help. This is a podcast primarily about AI and ancillary things associated with it.
What?
At the very end of last episode, you or I, one of us, said that we could use AI to subscribe to They Might Be Self-Aware. And I was talking about
that was
Cline.
sci-fi prediction for probably 10 years from now.
Right. I opened up my code editor, which has a plugin called Cline.
Yes.
For those of you unfamiliar, please listen to last episode. I was ranting and raving about it for a while. I'm not going to recover that sort of ground here.
Cline
anyway,
with a K.
Cline with a C.
Oh, it's C, sorry.
C-L-I-N-E.
C-L-I-N-E.
And I opened it up right after we were done recording, and I said, hey, can you subscribe me to They Might Be Self-Aware, a podcast
No way
with Hunter
I
Powers,
figured
Daniel
that out.
Bishop? And it opened up its own browser, searched, tried to use Google Podcasts, which is no longer a thing, tried to use Spotify, which required a login, and then found us on Apple Podcasts, and didn't subscribe me to it because it wasn't like logged in as me, for example, but rather it then directed me and said, here are a set of instructions to subscribe to They Might Be Self-Aware. This, go here, go here. You can also search on this other place. And not the regular use case for this kind of tool at all. This is supposed to be like, help me do this coding project. But in terms of an agentic AI, meaning like the agent aspect of give it a task and it has a thing that it can go do something with and come back to you with like answers. Oh my God. Kind of incredible. I wouldn't exactly call that doing research, but also really close to like, hey, please go and do this research for me. Apparently Google Gemini 2.0, which just came out, a new iteration on Google's big AI thing, supposedly has its own ability to kind of do some researchy type tasks on its own. Leave it alone for a bit, come back, it's done some cool stuff. Here's the results. Wild. Absolutely wild.
First off, awesome. Second off, you use the word agentic, which I feel is like a little bit of just a buzzword. Sort of like before the modern large language model revolution, sort of like everything could be construed as AI. And right now, most of the times when people are talking about AI, they are talking about large language models, which are more legitimately a form of artificial intelligence. And so now we have this subset of the AI space called agentic AI.
Right.
And I kind of feel like almost all large language model based AI could fall under agentic. Is there a clear delimiter there for you between what is agentic and what is not?
Yes. So for me, the difference between agentic AI and not non-agentic,
non-agentic,
is something that has the ability to say, I'm the main thread talking to you. Hold on a sec. I'm going to ask another version of me or a specific other model or just a tool or whatever to do something, come back with the results, and then I, the entity talking to you, will give the results. That to me is what agentic AI is. Earlier iterations of like ChatGPT, for example, I would describe as not agentic. You're just talking to ChatGPT. It just is a large language model that you're just chatting with. Now it and other tools out there have the ability to, even if in a very opaque way to the end user, it looks like you're just chatting with it. What it's really doing is like the main chat interface effectively pauses, calls other stuff, gets results, and then hands you that results as part of the conversation. And this is an evolution of tool calling or function calling or tool use, whatever. And I don't mean like a crow using a stick, except I basically do. It's that AI, the one thread that you would have been on, having access to just some other non-large language model code that it could call, of like, look up what today's weather is or whatever. And it just does that and gives you the answer in that main thread. So agentic AI is not just a tool, but a whole other LLM, whether it's an instance or just a separate thread of like, please accomplish this task and you happen to have these tools available to you and whatever. That's agentic AI.
I think I can appreciate that. First, I was thinking just in terms of ChatGPT. Well, I've had several examples where as part of my prompt, I'll say, oh, and please ask me any questions that, might help you arrive at a better answer.
Right.
I'll give
that
it
really helps.
A specific example so we recently hired a social media manager for They Might Be Self-Aware. If you've finally been seeing more of our content on TikTok and YouTube, that's thanks to Emily. Hi, Emily, if you happen to be working. What Emily does not probably know is I don't know anything about social media. I had no idea who we should hire and what we should be looking for. So what did I do?
Stop listening.
She's losing all respect. She had like this much before and it's gone away. No, I went to ChatGPT and said, look, let me describe the problems that we're having. We're running out of time to do this. We want to have a bigger presence. We have all these shorts. We can't get them posted, but they also need to be super relevant, etc. I said, please interview me. And when you think you have enough information, write up a job description for like the perfect person. And that's what it did. It asked me like 30 questions. I answered them all as best I could. It said, I know enough, wrote the job description. I shared it with a few people. They said, you're never going to find that person. But I was like, well, it doesn't cost any money to post a job description. Posted it. We found Emily, who's awesome. But I was thinking that was sort of agentic. But I think the difference is.
Was this ChatGPT?
It was ChatGPT, but it didn't decide on its own to interview me. And that, I think, is the difference. It decides on its own to use an external tool, or, I think you could view me as an external tool.
You would have been the agent in this.
Yes, but it decides on its own. I ask it a question. Hey, I'm trying to find someone. And they're like, oh, can I interview you first to get a better idea? That would be a more agentic approach rather than me explicitly saying, ask me the 20 questions that would best inform what this job should be and how to write a job description. It's the deciding on its own to call an external tool.
One distinction that I want to make here, which is you're describing a research task of like it needs to have thought of do this research, whereas the very slight iteration on that I was describing for agentic AI is already mid-task. It basically stops itself and says, knowing what I currently know, I need to ask another expert. And so like imagine if you were having this conversation with ChatGPT, but instead of asking you, it asked a different large language model that set of questions. That would have been agentic AI, where the one ChatGPT session you're doing talks to a different LLM and then comes back to you. In this case, you were the other large language model.
Well, I think
it kind of was like agentic, just not fully
it didn't choose to do it, though.
Agentic AI,
yeah. But I think it would be awesome if like it decided it wanted to talk to a human on its own and then figured out how to connect with them and reached out and got the information back.
Well, it needs to be told that that's something it can do, and then it
Correct.
has to be given that
Correct.
capability.
That is the difference. We're in alignment.
Now, I love that idea. This was our new startup idea. This is startup ideas with Daniel and Hunter. Maybe we'll have a fun little jingle.
Email invest at tmbsa.tech with your minimum. I think it's like a minimum $1 million, but there's no ceiling.
All right, sharks, here's my pitch. We have an AI who is a mediator for a discussion. It could be a debate. It could be a podcast. It could be whatever. But basically, you say, as a person, I am available to have a discussion of these types with somebody else, and I need you to find an appropriate person for me and moderate that discussion. And then it does that. Just like it's a social site, a social site where you and other people can sign up and say, these are the kinds of discussions I'd like to have. I want to do debates. I don't want to talk about these topics. I do want to talk about that kind of thing. Whatever that ends up being. And it, using AI, finds
Agentic AI.
Using Agentic AI, we got to get all the buzzwords in. It'll be hooked up to your calendars. It'll book time for you, and then it'll be there in a multimodal way, voice, maybe video even, just sitting on a phone call with you and helping moderate a discussion.
I like it. I'm in. Who else is in?
Right. Go ahead, and I guess we're just gonna in the show notes take a look. We'll have our bank account
Bitcoin address. I'll put a Bitcoin address.
Right. Yep.
There actually
Invest
will be
now.
one for reference. There will be a Bitcoin address in the show notes. Oh. Because why not?
Why not?
And if enough funds come in, we'll build it.
Yep. So send us your $1 million now, and we're going to build whatever that thing is I just said. We'll ask ChatGPT what to call it.
Okay. All right. Thanks.
Yeah. That actually wasn't a bad idea. I have some really bad ideas involving LLMs. That was not necessarily one of them.
Well, you mentioned multimodal as one of your keywords.
Yeah, what does that mean?
Multimodal means various forms of input, whether it's text or voice or video.
But multi. Yes. Multi of it, so not just the one.
But what I was thinking about was multi-universe. Maybe that is the real key to our next innovation, because apparently Google has discovered the multiverse, as they or at least they mentioned it in a press release for their newest Willow chip, which is probably a legitimate breakthrough in the realm of quantum computing.
Sure.
Are you excited? Have you been able to sleep since this announcement of Willow?
I absolutely love that they brought up this multiple universes sort of thing, because the whole, first off, quantum anything, I almost immediately start rolling my eyes, even though there are real use cases, presumably eventually, for these things. To even say parallel universes is like you're just trying to build buzz. The whole idea is that if you were to take a regular computer and give it this problem, it would take 100 squidjillion bajillion years to do, and then this, using nonsense, can make it happen in like 10 minutes or whatever.
Right.
And that's incredible. Like, to say, here's this wild math problem or whatever, and please solve that using, dare I say, AI, probably some sort of machine learning, something. I don't know. Whatever it is, like, able to do this very, very quickly. In terms of what the actual problems are and how this ends up being in like a consumer device 10, 20, 30 years from now, to say that they had to look into parallel universes to find that solution is a really weird way of saying, like, if it wasn't using this method, it would have taken forever, so we used a different one.
Yes, I think we need to give our audience like the lightest primer on quantum computing. Although I still don't know whether it's it makes sense. But in today's computer world, the computer that you're using to watch or listen to this podcast right now, everything at the very bottom, it boils down to ones and zeros, or binary code. Maybe you've heard that term. Maybe you've heard ones and zeros.
Electricity is going to or is not going to a little bit of a computer.
And we might call this a finite space because things exist as either a 1 or a 0. And binary provides a way for us to represent things in 1s and 0s. So there's a way of encoding or decoding a bunch of 1s and 0s to turn it into a programming language, to then turn it into words and videos and graphics. Everything's built up from 1s and 0s. But in a quantum space, or in quantum computing, it says that, yes, you can be a 1 or you can be a 0, but you can also be anywhere between the two, a blend of these, the 1 and the 0, which
for regular computers you straight up can't do.
You can't do. And this, if you imagine...
It can be all of them at the same time, kind of, also.
Yeah.
It's like the whole probability space between 0 and 1.
Yes. So yeah, there's it can exist in infinite states, and you don't necessarily know that state until you ask it what is the current value. You could maybe compare that to like the Heisenberg uncertainty principle, where we don't know
that's the
until
big balloon that blew up in the early 1900s.
Something like that. So that's a fundamental idea of quantum computing. It exists in infinite possibilities, which allows us to tackle much more complex problems. But that idea is inherently
like a big math problem.
Yes. Well, also things that it's still everything could be construed as a big math problem, but it's really about operating in higher dimensional space where there are more layers of things.
No, you said that there's multiple universes. Now we're talking about adding some extra dimensions into the mix.
Okay. So there's one more idea that I want to attempt to inform our audience on. So first is, instead of just a 0 or 1, it can exist anywhere between 0 and 1. And then the second thing, which is important, is that you are able to take, and this is where the new chip or the quantum architectures come into play. You're able to take these spaces and effectively stack them on top of each other so that you can analyze a whole bunch of these all at the same time. Whereas again, in traditional finite space, you have to look at each one individually to get its value. So not only can you look at them all at once, they can all have infinite values. And this is where Google suggests that perhaps in order to do this, and they're referencing quantum mechanics, that if we are existing in all of these states at the same time, then isn't this a close proximity to, if not the multiverse, in order to access all of these states at the same time in all of these different layers? We may have leveraged the multiverse, maybe, possibly.
Now, in the actual document, the on Nature.com, there's like an article. This is a accelerated preview, whatever. They, I won't quite say rushed it to publishing, but multiverse or universes, like that's never actually mentioned in the document. The document is called Quantum Error Correction Below the Surface Code Threshold, which to me, who knows? Maybe you can take that PDF, put it into Google's Notebook LM, and they'll tell you about it. But
yeah, you need to go to, so Google's blog is where they actually reference it. And the direct quote is, this mind-boggling number exceeds, so they're talking about the, in order to demonstrate the supremacy of this new chip, they ran a computer science problem that has existed for a long time and takes many hundreds of years to solve, theoretically. And they solved it in a very short period of time.
Yeah, like 5 minutes.
This mind-boggling number exceeds known timescales in physics and vastly exceeds the age of the universe. The age of the universe being how many computations that they made. So this, back to the quote, it lends credence to the notion that quantum computation occurs in many parallel universes, in line with the idea that we live in a multiverse, a prediction first made by David Deutsch.
Honestly, if that were true, I think that's a very interesting thing. A lot of philosophical issues to sort of untangle there, which I'm nowhere near self-aware enough to start delving into. But I do want to kind of cap off this discussion of quantum computing, if only because we have easily exhausted my knowledge on the matter, is on an article about this. They mentioned that Google says their next goal which is to say has not already happened, is to perform a first useful beyond classical computation that is both relevant to a real-world application and one that typical computers can't achieve. So it's cool that they can do this complicated math problem, but everything I've seen about any quantum computing breakthrough is we were able to do this big thing very quickly, and technically it is not actually any amount of useful yet, even a little.
Well, speaking of useful, we actually had one of our listeners leave a note, leave a question, which is, what is the implication on AI of quantum computing? Is there any intersection there? And I think the answer to this question is, so first, noting we're not there yet, but the first thing that it does when it becomes more mainstream is it allows us to build and train these models faster. One of the big advances of the Willow chip is that it makes errors far, 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 far less. And so it now is becoming something that could potentially use in a production system. And as you might imagine, there's a lot of math crunching that happens in today's existing AI algorithms. So it could apply those algorithms to data faster. The second thing is the ability to model this higher dimensional mathematics. So when we think about molecular structures, you want to create a full representation of every molecule in a human and how it's interacting and make predictions about that, whether it's to invent new drugs or make a better roller coaster. I don't know. It will be able to attack those types of problems, which today we just don't have the computational capacity to do. We are limited by our ones and zeros. So I think that's where the innovation will come in. But I don't know about timeline.
It's really interesting to think of the possibility of taking something that takes a really, really, really long time to do with the biggest supercomputers and computer clusters and so on, like these very large and power-hungry AI training centers that everyone seems to be spinning up these days, and then say, what if it was one computer in 5 minutes instead? So are we anywhere near the actual reality of that happening? No. But if we want to think of AI, of large language models, of whatever, as something that's close to the human brain in terms of it isn't just ones and zeros going back and forth, it's, weird little, I don't know almost anything about biology, but like something to do with neurons, and it's not just electricity got sent. There's like thresholds and like weird little wobbly bits instead of just it activated. To be able to model real life, real brain architectures, real ability to have these truly, truly complex systems. To say that what we have right now isn't, which of course it is, but like orders of magnitude more so. I think that eventually the hardware that we're working on today and tomorrow and 10 years from now is going to start to show up as a replacement, if not for everyone's personal computer, certainly for something that would ordinarily take a zillion computers a zillion years and becomes a very infeasible thing into something that is very feasible. And that's when you need to divest yourself of your NVIDIA stock, because finally everyone's going to stop buying up every chip that they can possibly pump out.
Well, there is one fear of quantum computing. It's like some people are afraid of AI.
CEO is terrified.
So when we get to the state where we can solve incredibly complex math problems in fractions of a second that are unfathomable today, something else, there's going to be a side effect, which is that all existing encryption is going to become moot, go away.
Because that is reliant on a 256-bit long, whatever, math problem.
And so what does this mean? Well, first, it means all traffic on the internet. Everyone would be able to see all traffic on the internet as plain text. You want to know what your neighbor's doing, what they're looking at, what their credit card information is, etc. Right. You'll just see it in plain text. Nothing is secured. Bitcoin, something that's built on a mathematical model, you would be able to access anyone's Bitcoin address and just take all of their Bitcoin instantly. Every credit card transaction, etc. It all becomes immediately, it's just like it's all wide open. All the locks, all of a sudden, it's the scene in the movie where they're in the prison and like every jail cell opens at the same time and everyone kind of walks out. Like that is everyone the arrival. That's the arrival of quantum computing, and that's the fear. And so we have already started to develop quantum proof encryption methods. but no one's really applying them yet because they're more expensive to use, and we don't really know when this is coming.
Anything that we know about that can already crack these codes. Yeah. And also, when it comes to cracking codes, if you need someone's password, it turns out a lead pipe is a lot cheaper than a quantum computing rig. You can just hit him in the knees over and over until he tells you, depending on how badly you want to know someone's password.
Do you think we reach AGI first or quantum computing in production first?
Boy, that is an interesting question. And
you're supposed to know.
We have quantum computing. You just said Google's got a chip. You're able to look at it.
A few episodes ago, we learned we have AGI as long as you...
Yeah, depending on who you ask.
Exactly.
We already have AGI. Depending on who you ask, we already have...
Depending on which universe you're in, of the multiverse. And there are multiverses where AGI already exists. There are multiverses where quantum computing already exists. And it's just a question of what the blend is that we're experiencing today.
It's not a 0 or a 1. It's somewhere kind of in between.
It is a race to self-awareness. And you have reached the end of that race here today on this episode of They Might Be Self-Aware. I think we've got one more episode this year coming to you, and we are going to reveal, this is a teaser, we are going to reveal our top 3 winners, each of us, in AI this year. What will it be? Who knows? I don't know. I still haven't figured out. I've been working on mine, but I'm not sure yet. I'm wondering if we're going to say the same things or completely different things. Could lead to some arguments. We might have to disband the show after the episode.
Right.
I don't know.
Fisticuffs. Yeah.
It's a little hard over video, but you never know. We could try. The episode right after the first episode of the new year, we're going to do our predictions for 2025, if that's something that's interesting to you. And if you want to...
It sounds like you're predicting then that we're not going to come to fisticuffs and a series-ending argument.
I think in some universes we will, and in some universes we will continue on.
I hope that you all are in the universe where you will see us at the beginning of 2025.
And Daniel, if they want to see us, are there any tricks to like finding out when a new episode goes live?
I've heard that you can ask Cline to subscribe you, or at least tell you where to subscribe to us, but that subscription is the important part. If you go to Apple Podcasts, if you go to Spotify, if you go to YouTube, we've got shorts on TikTok, not the full episodes. That's not how TikTok works. Wherever you find podcasts, you can find us. If you search for, or have your AI search for, They Might Be Self-Aware.
And if you have something you want us to talk about, leave a comment. Just as today, we did a whole segment based off of one listener's desires.
We haven't heard from a friend in a while. Do you think...
Well, I don't know.
Yeah, I wonder if he's okay.
Well, perhaps we'll find out next time, because you have been listening to...
They might be self-aware.